Good morning, students. This is the next topic in the chemical bonding chapter, that is molecular orbital theory. This is also one of the important topic in this chapter. According to valency bond theory, oxygen molecule is diamagnetic. Why we can say that it is diamagnetic? How can we say that? Because if any molecule having even number of electrons, then it will be diamagnetic. See, oxygen atomic number 8. Oxygen molecule, that means O2. In that O2 molecule, 2 oxygen atoms are present, 16 electrons are present. 16 electrons means even number of electrons. If any substance contains even number of electrons, that will be diamagnetic. So, according to valence bond theory, we can say that oxygen is diamagnetic, but experimentally it is paramagnetic. To explain this paramagnetic behavior of oxygen, Mulliken and Hunds proposed a new theory that is called molecular orbital theory. Molecular orbitals are formed by the linear combination of atomic orbitals, that is LCAO, linear combination of atomic orbitals of two same or different atoms. This is important point. Linear combination of atomic orbitals means the orbitals should have same energy or nearly same energy, and the orbitals should have same proper orientation, same orientation. The orbitals have same orientation. That is called linear combination. Next, the number of atomic orbitals are involved is equal to number of molecular orbitals are formed, just like hybrid orbitals. In case of hybrid orbitals, what we said, if two orbitals of the same atom should be intermixed with each other, then same number of hybrid orbitals are formed. Here also same phenomenon. The number of molecular orbitals are equal to number of hybrid atomic orbitals are involved. If two atomic orbitals are involved, two molecular orbitals will form. If 3 involved, 3 form. 4 involved, 4 form. Orbitals, not electrons. Next, these are two types. These molecular orbitals are two types. They are bonding molecular orbital, anti-bonding molecular orbital. Now we will discuss. We have to know what is bonding and what is anti-bonding. Bonding molecular orbital means the molecular orbitals are formed by the constructive interference of two same or different atoms, are called bonding molecular orbitals. Constructive interference means, see, let us assume this is orbital of one atom. This is orbital of another atom. We know that orbitals in orbitals electrons are present. Those electrons have wave nature. This is crust, this is trough, this is crust, this is trough. We know that very well. This is psi A and psi B. These are wave functions. This is wave function of this orbital of A atom. This is wave function of this orbital of B atom. Constructive interference means those are in same phase. Those should be in same phase. That means here crust is present in upper side and trough is present in lower side. Here also crust is present in upper side and trough is present in lower side. When these type of wave functions of orbitals mix with each other, then that is called constructive interference. In such process, molecular orbital is formed. That is represented by psi A plus psi B. Here crust is somehow big compared to here. That means this indicates what? These two are going to intermix. This is called constructive interference. Now, this bonding molecular orbital has less energy than atomic orbitals. Due to this type of mixing, bonding molecular orbitals are formed, but those are having less energy compared to atomic orbitals. Next, these are represented by sigma, pi and delta. That means these bonding molecular orbitals are represented by sigma, pi and delta letters. Next, anti-bonding molecular orbital. The molecular orbitals are formed by the destructive interference of two same or different orbitals. We will see what is destructive interference. See, here crust is present upper side and lower, here trough is present lower side, but here first trough is present, here crust is present next to trough. Here in this case first trough is present, next to crust is present. This is one orbital of atom, this is another orbital of atom. When the intermix, when these orbitals are mixing in this manner, then we get anti-bonding molecular orbital, that is called destructive interference, that is said to be psi a minus psi b, because these wave natures are cancelled to each other. That is why we used to represent like this. This is called what? Destructive interference. Here the point is, the bonding molecular orbital have, anti-bonding molecular orbital, not bonding, anti-bonding molecular orbitals having more energy than atomic orbitals. In case of bonding molecular orbitals, they are having less energy due to constructive interference, but in this case they are having more energy due to destructive interference. Next, these are represented by stars, sigma star, pi star and delta star. Those are represented by sigma, pi, delta. These are sigma star, pi star and delta stars. Next, these points are very, very important points. These are important points, no need to remember previous points. That is introduction of molecular orbital. These are very, very important. If n is less than or equal to 14, means the number of electrons, if number of electrons are equal to 14 or less, number of electrons is less than 14, less than 14 in given substance, then this configuration will come. This configuration means sigma 1s molecular orbital having less energy than sigma star 1s, which is less energy than sigma 2s, which is less energy than sigma star 2s, which is less energy than pi 2px is equal to pi 2py. That means both are having same energy. Which is less energy than sigma 2pz, which is less energy than pi star 2px is equal to pi star 2py. That means these two orbitals again have same energy. Which is less energy than sigma star 2pz. That means this is what? This is molecular orbital configuration. Molecular orbital configuration. If suppose n is greater than or equal to 14 in a given substance, that means if number of electrons are equal to 14 or more than 14, then this configuration comes. This molecular orbital configuration comes. That means sigma 1s less than sigma star 1s, which is less than sigma 2s, which is less than sigma star 2s, which is less than sigma 2pz, which is less than pi 2px is equal to pi 2py, which is less than pi star 2px, which is equal to pi star 2py, which is less than sigma star 2pz. That means if you observe these two molecular orbital configurations, one difference only there, that is here. In this case, in both cases, first sigma 1s comes, next sigma star 1s comes, next sigma 2s comes, next sigma star 2s come. But in case of n is less than 14, this configuration comes. That means pi 2px come after sigma star 2s, but in this case sigma 2pz come. Here after pi 2px, pi 2py, sigma 2pz come, but here after sigma 2pz, pi 2px to pi 2py. That is only difference in this case only. That is due to undergoing, that is due to energy difference between these orbitals. The energy difference. Because of that energy difference, in that case, these orbitals will come. Later these orbitals will come. But in this case, these orbitals will come first. Later these orbitals. That is the only difference. In the rest of configuration remain same. So these are the all the points regarding molecular orbital theory. Now we will discuss examples. If I discuss example, then you will get a clear idea of molecular orbital theory. See, MOID of H2. MOID, that means molecular orbital energy diagram of H2. Here two hydrogen atoms are present, each hydrogen having atomic number 1, each hydrogen having electronic configuration of 1s1. This is what atomic orbital, because it is present in atom. If an orbitals are present in atom, that is called atomic orbitals. How molecular orbitals are formed? When atomic orbitals are undergo either constructive indifference or destructive indifference, then molecular orbitals are formed. For that purpose, first we have to draw two lines. This line indicates for hydrogen atom, this line indicates for another hydrogen atom. Hydrogen having which configuration? 1s1. Here also 1s1 configuration. That means these are atomic orbitals. When these two atomic orbitals combines, how many molecular orbitals are found? Two molecular orbitals. They are sigma 1s and sigma star 1s. These two are atomic orbitals. These are molecular orbitals. Next, after forming orbitals, electrons are filled. How many electrons are present in atomic orbitals? 2. This is one electron, this is one electron. Now these two electrons comes in this orbital, because any orbital can have maximum number of 2 electrons. After filling 2 electrons, then electrons jumps to this orbital, but here only 2 electrons are present, so those 2 electrons are present in sigma 1s orbital. Now this is which orbital? Bonding orbital. This is anti-bonding orbital. That is why we represent like this, because bonding molecular orbital having less energy compared to atomic orbitals. That is why it is drawn below the atomic orbital, but anti-bonding molecular orbital is drawn above the atomic orbitals. Why? Because they are having more energy of atomic orbitals. Now we have to calculate bond order. The formula for bond order is number of bonding electrons minus number of anti-bonding electrons. Number of bonding electrons minus number of anti-bonding electrons by 2. Bonding electrons means the electrons which are present in bonding molecular orbital is called bonding electrons. How many? 2. 2 minus, here no electrons, so 0 by 2, total 1. That means what? Bond order means what? What is the definition of bond order? The bonds between two atoms is called bond order. Between hydrogens, one bond is present. So experimentally also it can be proved. So it's electronic configuration. Electronic configuration, molecular orbital configuration. Sigma 1s, it contains how many electrons? 2. So this is molecular orbital configuration of hydrogen. Next, MOID of B2. MOID of B2 means, see, I show here, already it is present. B2 means 2 boron atoms. What is the electronic configuration of boron? 1s2, 2s2, 2p1. See, 1s2, 2s2, 2p1. This is the electronic configuration of this boron atom. This is the electronic configuration for this boron atom. That means these are atomic orbitals. When these atomic orbitals combines, then molecular orbitals are formed. See, 2 atomic orbitals, 2 molecular orbitals, 2 atomic orbitals, 2 molecular orbitals. Here see how many orbitals? 1, 2, 3. Here 1, 2, 3. How many orbitals? 3 plus 3, 6. Then 6 molecular orbitals will form. Out of 6, 1, 2, 3, 4, 5, 6. Next, after forming molecular orbitals, electrons are filled. Here 2, 2. How many? 4. Out of 4, this sigma 1s contains 2, this sigma star 1s contains 2. So electrons are completed in this case. Here also 4 electrons are present. 2 plus 2. How many? 4. So here this sigma 2s occupies 2, sigma star 2s also occupies 2. So here till here molecular orbitals and electrons are filled. Now this is, see, this is carefully. Here are how many orbitals? 3. Here 3 3, total 6. So 6 molecular orbitals are found. 1 2 3 4 5 6. Out of 6, 3 orbitals comes under 3 orbitals comes under bonding molecular orbital, 3 orbitals comes under anti-bonding molecular orbital. Compared to atomic orbitals, these are having less energy. That is why those are drawn below atomic orbitals. These are having more energy. That is why they are drawn above the atomic orbitals. Now, after forming atomic orbitals, electrons are filled. How many electrons? 2. Those 2 electrons are occupied in pi 2px, pi 2pi. We are discussing about which one? Boron. That is B2. In case of B2, how many electrons are present? 10 electrons are present. How many? 10 electrons. So these are less than 14. In case of less than 14, which comes pi 2px, pi 2py come. In case of less than 14, after sigma 2pz, then pi star 2px, pi star 2py, then sigma star 2pz. I discussed already these points. Now, bond order. Bond order means what? Number of bonding electrons minus number of anti-bonding electrons by 2. Bonding electrons means the orbitals which are below, or with the orbitals which are not having stars. Sigma 1s, sigma 2s. These are bonding orbitals. How many electrons? 1 2 3 4 5 6. 6. How many anti-bonding electrons? 2 4. Total 6 minus 4 by 2. Then 1. That means bond order is 1. This is electronic configuration. How can we write sigma 1s2 less than sigma star 1s2? Why we should put less than symbol? Because this orbital having less energy compared to this. This orbital having less energy compared to this. Sigma star 1s2 less than sigma 2s2 less than sigma star 2s2 less than pi 2px 1 is equal to pi 2py 1. That's it. That is the molecular orbital configuration. For what? P2. Next, moid of N2. This is important. 2 nitrogens. Nitrogen. Atomic number 1s2 2s2 2p3 1s2 2s2 2p3 1s2 2s2 2p3. Here this is 14 electron system. In that case also pi 2px, pi 2py comes first after filling sigma star 2s, then sigma 2pz come. How many electrons? 14 electrons. 1 2 3 4 5 6 7 8 9 10 11 12 13 14. After forming bonding molecular orbitals, electrons are filled. Here 2 2. So these electrons can be filled here only. Next, here also these electrons can be filled here only. Now here how many electrons? 3 plus 3 6. Those 6 electrons can be filled here only. They cannot be filled here because after 6 only 7th electron come here, because here 3 orbitals are present. Each orbital can have maximum number of 2 electrons. So electrons can be filled here only. Total 6 electrons. Then what about bond order? Bonding electrons minus anti-bonding. Bonding means without stars. 2 2 2 2 2. Total 10. 10 minus anti-bonding means stars. 1 2. That means 4. Here no electron. So 10 minus 4 by 2. 3. So this is the bond order. That means that indicates that between 2 nitrogens 3 bonds are present. This is electronic configuration. That means sigma 1s2 less than sigma star 1s2 less than sigma 2s2 less than sigma star ps2 less than pi 2px2 is equal to pi 2py2. Because why is equal to is mentioned here? Because both are having same energy. Why 2 2 mentioned? Because both orbitals having 2 2 electrons. Pi 2px2 is equal to pi 2py2 less than sigma 2pz2. Nitrogen is diamagnetic because in this molecular orbital configuration there is no unpaired electron. So that if there is no unpaired electron, that comes under diamagnetic. Next one, moid of O2. Moid of oxygen atomic number 18 electron configuration 1s2 2s2 2p4. This is 16 electron system. That means first sigma 2pz comes after sigma star 2s, then pi 2px 2p. This is first. This is the line indicates for one oxygen atom. This is the line indicates for second oxygen atom. This is the atomic orbitals of this oxygen atom. This is the atomic orbitals of this oxygen atom. These two combines 2 molecular orbitals. These two combines 2 molecular orbitals. Here 3 3. Total 6. 1 2 3 4 5 6. After forming a molecular orbitals, electrons are filled. 2 plus 2, 4, 4. 2 plus 2, 4, 2, 4. Here how many electrons? 4, 4. Total 8. 1, 2, 3, 4, 5, 6. Here 7, 8. Because 3 orbitals are filled. Then it goes to higher orbital, 7, 8. If you observe this configuration, this molecular orbital configuration, two unpaired electrons are present. If unpaired electrons are present, then that is paramagnetic. Like that we can say that oxygen is paramagnetic by using molecular orbital theory. Then what about its bond order? Bond order is equal to bonding electrons. That means without stars, 2, 2, 4, 6, 8, 10. Total 10 electrons. Anti-bonding means stars, 2 plus 2, 4, 5, 6. These two unpaired electrons are also anti-bonding because those are present in anti-bonding molecular orbitals. Total bond order is 2. That means between two oxygens, 2 bonds are present. Electron configuration is what? Sigma 1 is 2 less than sigma star 1 is 2 less than sigma 2 is 2 less than sigma star 2 is 2 less than sigma 2 pz2 less than pi 2 px1 pi star 2 px1 is equal to pi star 2 p1 by 1. This is paramagnetic. Next, one more example, CO. In case of CO, this is the atomic orbital configuration for oxygen. This is the atomic orbital configuration for carbon. Two orbitals, two orbitals are formed. Two atomic orbitals, two molecular orbitals. Here 3 plus 3, 6. 1, 2, 3, 4, 5, 6. After forming molecular orbitals, electrons are filled. 2 plus 2, 4. 2 plus 2, 4. So electrons are filled. 2 plus 2, 4. 2 plus 2, 4. Electrons are filled in molecular orbitals. Here how many electrons? 2 plus 3 plus 1, 4. Here 2. Total 6. 2, 2, 2, 6 are filled. Then what about bond order? Bonding electrons. That means 2, 2, 2, 2, 2. Total 10 electrons. Bonding electrons means electrons present in bonding molecular orbitals. Anti-bonding means stars. 2 plus 2, 4. 10 minus 4 by 2. Total 3. That means between C and O, 3 bonds are present. Here you have to remember one point. That is, in case of CO, total electrons are how much? 14. 10 bonding plus 4 anti-bonding. In case of nitrogen also, total electrons are how much? 14. In both cases, bond order is the same. Here bond order 3. Here also bond order 3. So what is the point here? What is the important point here? If number of electrons are same, bond order is also same. That is very, very important. If number of electrons are same, bond order is also same. Next, some more points. For all isolated electron species, that means number of electrons are same, bond order is same. Some more points. If the bond order is 0, then molecule does not exist. If bond order is 0, then that molecule does not exist. Next, some shortcuts are there. If n less than 14, if n less than shortcut, these are shortcuts. If n less than 14, then anti-bonding electrons are 4, then the remaining are bonding electrons. But if n is greater than or equal to 14, then bonding electrons are 10, remaining are anti-bonding. I repeat this point. If n less than 14, anti-bonding electrons are 4, but bonding electrons are the remaining are bonding electrons. But if n greater than or equal to 14, bonding electrons are 10 and remaining are anti-bonding electrons. If you remember these points, then you can solve some questions like this. I will show those questions, types of questions. Sometimes you may get these type of questions. Out of O2 and O2 plus, which is having more bond order? Sometimes you may get these type of questions. Out of O2 and O2 plus, which is having more bond order? O2 16 electrons. Here also, here 15, because 1 plus means it loses 1 electron. This is n is equal to, both are n is equal to greater than 14. That means bonding electrons are how many? 10. So anti-bonding are how many? 6. In this case, bonding electrons are 10, anti-bonding electrons are 5. Then what about bond order? 10 minus 6 by 2. Here 10 minus 5 by 2. 10 minus 6 by 2 means 4 by 2. That means 2. Here 5 by 2. That means 2.5. In which case bond order is more? In this case. Sometimes you may get a question like this: out of O2 plus and N2 plus, which is more bond energy? O2 plus means 15, N2 plus means 13. This is N is equal greater than 14. So bonding electrons are how many? 10. Anti-bonding electrons are how many? 5. 10 minus 5 by 2, how much? Bond order 2.5. In this case, N is less than 14. So anti-bonding electrons are in this case 4. But bonding electrons are how much? 9. 9 plus 4, 13. So bond order is 9 minus 4 by 2. That means 5 by 2. So 2.5. So in both cases, bond order is same. In both cases, bond order is same. So that is the way to calculate bond order. This is all about anti-bonding. This is all about molecular orbital theory.